Okay, we're going to try and tackle this question. Find 1, the equation of the line passing through the points 2, 1 and 4, 6, and 2, find the equation of the perpendicular bisector. Okay, well let's start this off by drawing a little diagram just to make sure that we know what we're doing. Okay, so say that this is my point 2, 1. My other point is over here somewhere, and that is 4, 6. Okay, so first of all what I want to do is I want to figure out the equation of the line that joins these 2 points up. Okay, so we know that that is going to be of the form y equals mx plus c. Okay, so m being the gradient of this line and c being the intercept where it crosses the y-axis. Then for the second part, so that's the first part of the question, and the second part asks us to find the perpendicular bisector. Well, perpendicular means that it is at right angles to this line, okay, and bisector means that it cuts the line in half. So we're going to have to find the midpoint. Okay, so the midpoint somewhere here. Okay, so that's the first thing that we're going to need to find out, and the midpoint will be x1 plus x2 over 2. So you're finding the average of the two x coordinates, y1 plus y2 over 2. Okay, so that will be the coordinates of our midpoint. Once we've got that, we can work out the negative reciprocal of the gradient to then determine the equation. Oh, undo that. That needed to be a straight line. Okay, we need to work out the perpendicular bisector, and to do that we need to work out the negative reciprocal to determine the gradient of this new line that will meet our original line at right angles. Okay, so the equation of this line will be of the form y equals the negative reciprocal of our original gradient. Okay, so reciprocal means 1 over the gradient, negative obviously means minus, plus, and I'm going to put this as a capital C because this C will be different to our original C. Okay, so this is where the large capital C is where this blue line intersects the y-axis, and this smaller case c will be where our original line crosses the y-axis. Okay, so we have our method, and we're now going to tackle part 1, and we're going to find that equation of the line that goes through the point 2, 1 and 4, 6. Okay, so first of all we're going to start off with that general equation, y is equal to mx plus c. Okay, and it is this m, the gradient, that we're going to work out first. Now the way to do it, if you remember, is to work out the difference in the y's divided by the difference in the x's. So m is going to equal the difference in the y's, so 6 take away 1, all over 4 take away 2. So we get 5 halves. Okay, so m is equal to 5 halves. So our line, the equation of our line is y is equal to 5 halves x plus c. Okay, and we now finally need to work out what this c is, and the way we do it is by substituting in either the coordinate 2, 1 or 4, 6. Okay, or rather any point that is on that line. It will give us our c. So I'm going to substitute in 2, 1. So sub in 2, 1. So y is 1. We have 5 halves times x, which is 2, plus c. So 5 halves times 2 is 5. So 1 is equal to 5 plus c. So c must be equal to minus 4. So the equation of our line must be equal to y is equal to 5 halves x minus 4. Okay, so what we've got is our equation of the original line, which I've moved up here. Okay, and we're now going to move on to part 2, and that is asking us to find the equation of the perpendicular bisector. Now, if we remember our method, the first thing that we've got to do is work out what the midpoint is. Okay, so the midpoint, so midpoint of the two coordinates is the average of the x values. So 2 plus 4 over 2, and the average of the y values, so 1 plus 6 over 2. Okay, so the midpoint is actually equal to 3 and 7 over 2. Okay, so that's our midpoint. Now, we need to find the perpendicular bisector, the equation of that line. So I'm just going to change the colour to, let's try brown. Okay, so we know that the perpendicular bisector will have the equation y is equal to minus 2/5 x plus capital C. Okay, now where has that minus 2/5 come from? Well, it is the negative reciprocal of 5 halves. So the reciprocal is that fraction flipped upside down, and it has been made into a negative. Okay, so we've got y is equal to minus 2/5 x plus c. And now all we need to do is substitute in our midpoint. Okay, and that will give us the perpendicular bisector that passes through that midpoint. Okay, or the perpendicular line that passes through that midpoint. So sub in midpoint, so we're going to have our y value is 7 halves is equal to minus 2/5 times 3, our x value is 3, plus our capital C, and it is the capital C that we are looking for. So 7 halves are equal to minus 6/5 plus C, So then I'm going to add 6/5 to both sides, okay, and I'm going to make the denominators both the same in one step. So 7/2 is going to become 35/10 because I'm multiplying top and bottom by 5, and 6/5 is going to become 12/10. Okay, it has become positive because I've moved it over to the other side of the equation, is equal to c. So c must actually be equal to 47/10. So our final solution to this problem, our equation for the perpendicular bisector, is y is equal to minus 2/5 x, and our capital C was 47/10. And that is our final answer.